So in today's video, we're going to just quickly discuss how to do the Laplace of this question. So they are not asking you for the region of convergence, we're only asking you to solve the Laplace. So as we know, the Laplace formula is integral minus infinity to infinity into the signal, into this, into that. Alright. So just apply that there. We will get minus infinity into infinity right away. I can tell you because we have u of t, which is a step function. It looks a bit like this. This is how your u of t will look. So basically we know u of t gives a value of 1 only from 0 onwards. So this I can change to 0 to infinity if I make this 1. So 0 to infinity sine omega t into e raised to minus st dt. Now rather than having to follow the UV formula, it's going to lead you really nowhere. Let's do it this way. Now we know, this is just a formula, okay? This is not really part of the solving. We know that sine theta is equal to e raised to j theta minus e raised to minus j theta upon 2. If you were not aware of this, this is pretty important. It does come a lot in Laplace transform, and you'll find this formula quite useful when solving Fourier transform as well. So just keep that in mind. For cos, it is the 2j, okay? For cos, you have to put plus and you don't put a j. It's just 2. So this is our formula for sine. Apply this over here where your theta will be omega. So 0 to infinity e raised to j omega t minus e raised to minus j omega t upon 2j into e raised to minus st dt. Pretty simple now. We just multiply this inside. Integral 0 to infinity. I told you when you're multiplying two exponential numbers with the same base or the same root number, you can just add the exponents. So I'm just going to do j omega t, and because it's minus st minus e raised to minus j omega t minus st dt upon 2j. Now what I'm going to do here is I'm just going to take what's common. So t is common both places. I'm just going to take t common. You can actually take the 1 by 2j out because it doesn't have a t value, and hence it anyways is not going to be integrated, so we can take it out. So just a sec. Okay, so from here we can see my answer will be e raised to, I'm going to take say minus t out. That way I'm left with s minus j omega here, yes, minus e raised to, again minus t out, so s plus j omega, yeah. And that's how you do it till here. So just integrate it. It's pretty simple. I will show it to you on this half. Integrating this would look a bit like this. 1 by 2j. You write the e raised to term like so. I will write it like this: e raised to minus t into s minus j omega, and then you divide it by the non-t terms. So that's minus because that's minus is out, and whatever is not t will be put inside the bracket, s minus j omega. And just repeat the step for the other one, e raised to minus t, but this time it's s plus j omega, and divide it by the non-t version, which is s plus j omega, and put your limits, which is 0 to infinity. Next step is you put the limits inside. I want to mention that because we're not looking for region of convergence, it will be much easier to just directly solve the Laplace. So let's quickly put the integral inside, sorry, the limits inside. Okay, so I don't know if you noticed, but this is how I did it. I did this infinity inside this minus 0 in this. Of course, when you're opening the brackets and you're minusing it, this will get minus and this will become plus. I've kept the denominators. You can, if you want, after the step, go ahead and remove your denominator minuses, bring it up if you want. It doesn't matter to me because I know e raised to 0 is going to be 1 and this is also going to be 1. So right away I can tell you that this is both going to be like 1 upon this. Here, if it was region of convergence, we would do the entire, the s is equal to sigma plus j omega, and then we put that there, and then we find sigma values for getting this entire term as 0, where this will be positive and this should be positive. But we don't have to do that here. If you do want to know how to do that, go to the previous videos of how I was solving ROC. We do that particularly to find ROC. For Laplace transform, it's not required. We can directly assume that this is going to go according to the way we want it, and the final term is going to be e raised to minus infinity itself. So yeah, as we know, e raised to minus infinity, e raised to minus infinity is equal to e raised 1 upon e raised to infinity, which is 1 upon infinity, which is 0. In case you didn't know, that's how we get 0 there. So we know e raised to minus infinity into whatever is going to give me 0, and so will this term. So I can directly see this entire term is 0. So I mixed in 0 minus 0. Minus and minus become 1. So plus, and I know this is 1, right? So plus 1 by s minus j omega. This is minus, that minus comes up. 1, because e raised to 0 is 1. S plus j omega. Yeah, so as you can see, you've really shortened down the answer by just putting in 0 here and putting in 1. You should just know this by now. When you're doing ROC, it's not as straightforward. You are going to do it this way anyways. Yes, you will get your Laplace transform this way. But the reason we go through that entire previous step of making s into sigma plus j omega is to find your, find the limits to draw your region of convergence. Anyways, going on. Now we get 1 by 2j, and we're just going to do really quick LCM. You just take this up, multiply these two, and you're going to get, because this is an a minus b, a plus b formula, we can just write it as s square minus, so we're going to write this as j square omega square, and I'll tell you what you can do about that in a second. That's your denominator. Just put that to the top. You get s plus j omega minus s. Minus and minus become plus j omega. Really quick, j is imaginary, right? So actually j is equal to root of minus 1. So j square is just minus 1. So I have j square here. I know that's going to be minus 1. And because I have a minus here, that's going to be plus. So I have 1 by 2j s square plus, because that's minus 1 minus plus omega square. And on the top, I can just directly do this here. I'm sorry if the camera is not clear. Okay. S minus S, that goes. J omega plus j omega, that's 2j omega. 2j and 2j get cancelled. And your final answer is omega upon s square plus omega square. I'm so sorry, that's not written well. But yeah, your final answer was equal to omega upon s square plus omega square. And that's how you find the Laplace to this question. Yeah, so that's just Laplace, no region of convergence in this one.